So this is a Dynamixel AX-12A Servo. I got these servos from a college club working on robotics, and they are very nice robotic servos. However, my previous experience with servos was only with PWM-controlled hobby servos, and I didn't understand at first how these works. And these servos work very differently from hobby servos that I was used to. So this video will be about how these servos work so that you don't have to be as confused as I was when I started out. So here we have a normal PWM controlled servo that would normally come in any Arduino kit and is very common among hobbyists. Now this control is pretty simple. You have 3 pins, one's for ground, one's for power, and the other is your PWM data wire, which tells the servo which position between 0 and 180 degrees it should be in. Now, that's all fine and dandy, but these servos are a bit more complex. They also have 3 wires, a power, ground, and a data pin, but instead of being controlled by a PWM signal, they're actually controlled by the serial port on the Arduino. Instead of a value between 0 and 255, they're fed a data packet that is specific to the servo that it's being received by. So in every data packet, you need to know a few things in order for it to actually work. You have to know the ID number of the servo, you have to know its baud rate, which frequency it communicates on, and you also have to know the protocol it uses. I did all the work to figure it out on this servo, and I wrote it down on the side. This servo has an ID number of 1, baud rate of 1 million, and it uses protocol 1. For AX-12A servos, this is actually the default settings for every servo, so if you buy these just straight up, then this is what it should be. Now over here I have the setup for how I control this servo. I'm using an Arduino. There's multiple microcontrollers available for these servos that are sold by Dynamixel and ROBOTIS. I chose to use an Arduino because that's what I'm familiar with, and that's what a lot of hobbyists use. On the Arduino I have a shield that is an official Dynamixel shield. There's a couple of third-party brands for this as well. I chose to go with the Dynamixel shield because it had better documentation on it, and tech support knew what to do with it. You don't have to have a shield to control a Dynamixel servo. You can make it change positions and set it to a certain position using just the plain Arduino board if you look up the correct libraries. However, there's not a way to receive any data from the servo, because fun thing about these servos is has a lot of sensors inside of it. So it can actually receive packets of information for instructions, but it can also send back information such as error messages, the internal state of the servo, such as its temperature, and also its position. So you can get real-time updates on what position the servo is at instead of having to have an additional potentiometer in your robot design. Now for the shield, I have it hooked up to my power supply over here. The optimum voltage for these servos is 9.6 volts. And I have it hooked up on these terminals over here. This is where I have the Arduino hooked up to my computer using its own serial port. And the servos are connected through these ports here. Now you might notice that there's not that many of them. Fun thing about these servos is that they can be daisy chained. So there's 2 ports on the actual servo. I can take another cable and I can attach it here. And I can also hook up an additional servo as many times as I want, and they'll still work. Because these servos have different ID numbers, this is ID number 1, this is ID number 2, I can specify which servo will receive instructions. So if I tell the servo to move to position 100 to 100 degrees, then, and I say servo number 1 move to 100 degrees, only servo number 1 will move, and not servo number 2 as well. Now, for the actual use of the Dynamixel shield with this servo, first, this switch here controls whether or not there's power going to the servo. Over here, you have two settings. There's the Dynamixel setting and the UART setting. When you're uploading a sketch from the Arduino IDE onto your Arduino board, it's important that you have it switched to the UART setting. This is because that your computer communicates through your Arduino through the serial port, and that serial port is being used to communicate with your servo. So if something's already taking up that channel, it's going to cause some interference, and there's going to be an error when you upload your sketch. So when you upload, always turn the switch to UART, and you hit upload on your computer. Once you're done, you can flip it back to the Dynamixel setting and turn it on. Now, the sketch I have uploaded is a simple position mode sketch, so it just turns, it's one of the example sketches, it will just turn the servo to a specific position and back again over and over. So I tend to leave it off because the sound gets pretty annoying. Now on my computer I have an example sketch from the Dynamixel Shield Arduino library already loaded up. And I'm going to flip this switch on the shield from Dynamixel setting, move that so you can see, from the Dynamixel setting to the UART setting. By moving it to this setting, it ensures that the serial port that your computer is using to communicate with the Arduino is open and there's no interference or errors when uploading the sketch. So now that it's uploaded to the board, I'm going to flip the switch to Dynamixel, and then I'm going to turn on the servo. Now, because these can be daisy-chained, I can show you how that works. First, you take the wires that come with the servos and you hook it up to the other port. And I'm going to hook it up to servo with ID number 2. This servo uses the same baud rate and protocol number as the original. Now, the data packet is being sent to both of these servos, but because in the code I have specified that I want servo ID number 1 to be the one that moves, we should only see this servo moving. Put those together. So there you go. And similarly, if I change it to servo ID at 2, and I re-upload the sketch, now the second servo is the one that moves. So that's how that works in a nutshell with the actual operation of this board in order to write to the servos. However, it's also important to receive information from your servos as well. And at first I had a lot of trouble with this. You can't, usually when troubleshooting things on the Arduino IDE, you would have it print to the serial monitor, and you'd be able to monitor that on your computer screen. However, the serial port that an Arduino Uno has is being otherwise preoccupied by communicating with these servos. So if you try and open up the serial monitor, you're going to get a lot of jumbles of information that you can't read because it's in the servo's language, essentially. So these example codes on the Dynamixel Shield library, they have used software serial. So it's essentially hijacking the PWM pins on the Arduino Uno and having them pretend to be serial ports. In this case, it uses pins, I don't know if you can see that, pins 7 and 8 as the RX and TX pins, or the receiving and sending pins for another serial port. Unfortunately, it's not as simple as telling the serial monitor to look at different pins on the Arduino IDE. So you can't quite do that. And a solution that I found, one solution is ordering a LN101 serial monitor device, which is also sold by Dynamixel, that you can plug directly into your board. If I can find the end of the plug here. You can plug this device directly into your board and then into your computer, and then you can monitor your signals. So I have that plugged in, and you have to download an application called RoboPlus. And using this, you can open the RoboPlus terminal, hit Setup, Connect, and you select which port you'd like, and the baud rate. In this case, I have the baud rate at 115,200 bits per second. So now, I can see the output positions in the terminal. So if you either can't get an extra piece of hardware to monitor another serial port, or you don't want to, you can also jerry-rig it using another Arduino. I'm using an Arduino Mega. It can work just as well if you're using an Arduino Uno, but this is just what I had on hand. So what I do is I hook up the pins 7 and 8. These are the pins designated in the example code as the software serial pins. Make sure that you hook up, I hook up pin 8 to the TX pin 1 on the Arduino Mega, and pin 7 to the RX pin 0 on the Arduino Mega. And on my computer, on your computer, you gotta open another instance of the Arduino IDE. You can do this by simply re-clicking on the icon for the Arduino IDE, and in your taskbar it should show up as 2 separate icons instead of just one. Now, when I go to the first one, which has my example code for controlling the servos, this should be hooked up to an Arduino Uno. When I go under Tools, and I go to Board, it should say Arduino Uno, and Port. In my case, this port is COM6, and it says Arduino Uno next to it. So I know that this sketch is writing to this board. So what I'm going to do is I'm going to flip the switch for UART. I'm going to hit Upload on my sketch. Once that's done, I'll flip it back to the Dynamixel setting. Now, on the other instance of Arduino, if I go to Tools, under Board, it should say Arduino Mega, designating this board, and under port it will say, in my case, COM7, which shows an Arduino Mega. So that way I know that that sketch is writing to this board. The sketch for this board is incredibly simple. All you have to do is hit serial.begin, and in here I'm writing the baud rate, 115,200, and that's all I have to do, so it's monitoring the serial port. And in this instance, I'm going to hit Control-Shift-M to open up the serial monitor, and then I will turn on my sketch. Now for this, I keep having to hold the reset button in order for results to show up in the serial monitor. But as you can see, I'm getting the present position after every turn in both degrees and raw values in the serial monitor. So that's one way you can monitor data from these servos. Now, for simplicity's sake, I am going to be using the LN101 serial monitor for the rest of this video, because I do have it, and it does make things easier instead of having to jerry-rig it with another Arduino. So, next, we'll address the problem of you have a servo, but you do not know what its ID number is, or its baud rate, or its protocol. Thankfully, there's an example sketch in the Dynamixel Shield library that can help us out. This sketch is called Scan Dynamixel, and what it basically does is it will go through every ID number, baud rate, and protocol number combination that are possible for these servos, and it will tell you what it's found. So currently I have two servos hooked up to it. Let's say for the sake of argument I don't know what their ID numbers are. I'm going to turn my switch over to UART and upload the Scan Dynamixel sketch. Now on the screen, after I've turned it on, I can see it's scanning different baud rates, and as it hits baud rate under protocol 1, hits baud rate 1 million, I can see it showing up as ID 1 and the model number, and ID 2. And then once it's done scanning all the baud rates, it then tells me that it has a total of 2 Dynamixels found. So I know that these two servos, one of them is 1 and one is 2. I don't know which one yet. But I do know their baud rate and protocol number. Now the smart thing to do when testing out a servo is to disconnect one of them and just test them one at a time. So if I run the Scan Dynamixel code on this servo, I will see that it is indeed ID 1, baud rate 1 million, and protocol number 1. It's very useful to write these down on the actual servo, so I just took a piece of tape and put it on the side of the servo with all this information on it. That way you can keep track of what servos you have and make sure that you're not you don't think you're working with ID number 1, you're actually working with 2. So now that we know the information for this servo, we can change it if we want to. So maybe I don't want the ID to be all the default values. Maybe I want it to be ID 17 instead of ID number 1. So there's another example code in the Dynamixel Shield library that allows us to change this. So I'm going to go into the library and I'm going to pull up ID. The name of the file is just ID. So what this code does is you feed it the present ID number of your servo along with its baud rate and its protocol. And it can first pings it to make sure that that is indeed the correct current ID. Then it sets a new ID to the servo, and it will tell you if that has been successful. It also changes it back to the default ID, so we'll change it back to 1 afterwards. I commented out this code because I don't want it to do that. I want it to just change it to what I want and it to stay there. So I will set my Dynamixel shield to UART, and I will upload this sketch. So once the sketch is started, I can see on my output screen that protocol 1, ID number 1, ping succeeded, and then it says ID has been successfully changed to 17. Now, I don't actually want the ID to be 17, but if I did, that's how I would go about it. So I'm going to go and change this back to ID number 1. When changing your ID back, you always want to make sure that you also change your present ID to what it currently is, and not the default ID. And you can also double check this, if this was indeed successful, by going to the scan Dynamixel code and rerunning that.